Okay, hello students. Today in this video, I'm walking through Unit 2, Algebra 2, lesson number 9. And the lesson number 9 is about understanding let's describe the end behavior of the polynomial. So how does it look like on either side of the x-axis, how the output change? How can I identify the end behavior of a polynomial function from its equation? So let's go straight away to the problem. So question number one is match the polynomial with its end behavior. So if you see there's a B, C, D, and on the right you have 1, 2, 3, 4, and checking on which one matches what. So the first one is, if you look at it, this first one, this is a linear equation. So what is a linear equation? Means it is a line, right? Now there is a -2 here, so that means it is the, if I draw the grid, if you remember from the algebra one, it starts from 3 here. That's where it starts. The vertical intercept is 3, and then the slope is here, which is -2 over 1. That means it goes 2 down and 1 right, and you go 2 down, again 1 and 2 and 1 right. So you get a line like this, which is going down. All it means is is the end behavior. So what do you think is the end behavior? So basically it means as x becomes very large, positive value this way, and you can see the end behavior. This goes down to, it means the y values here. So every time you increase this, when you increase this, the this y value become very large, negative value, right? Negative. So minus infinity. So this goes to minus infinity, or you can say as x uh, become very larger and larger positive value, that means plus infinity, the y value, the graph goes to minus infinity. That's the understanding. But if you go up this side, that means as x becomes very large, negative infinity, that means very, very large negative numbers, that means the y goes up. See, that means this becomes very large positive, and so plus infinity. So this is how you explain the first one. And the second one is B. What is B? Yeah, so you have to decide which one is correct. Now here, this is a quadratic because the degree is 2. The highest exponent is 2 here, and it is positive 1 here. So the leading coefficient is plus x square. I mean leading term, but the leading coefficient is plus 1. So that is plus 1. And when this is going to be a parabola, and maybe this is x-axis and y-axis, or I'm going to make it very nice. Maybe uh, if this is x-axis and y-axis, so kind of the graph will look like kind of something like see. So it means what we are more concerned is how does the graph behave as x becomes very not in between. We are not worried about here. We are more worried about if x becomes very large, positive. This means going on encouraging larger and larger to a positive infinity, and then this goes up. So that means the y values become plus infinity, and that's happening for both sides. If you become x become very large negative number, that means x become very large negative number. The the y coordinate become very large positives, means up. That means this is up and this is up. On either side, as x becomes very large positive and large negative, the graph goes up. I hope this makes sense. Question number, this is C. See, if you watch this, look at the degree. Degree is 3. So because degree is 3 and it is positive, that means it's a cubic polynomial. This is a cubic polynomial, and of degree 3, that means the graph has to be something like this, right? And I've shown this already in my earlier video also. It's same kind of a question, x-axis, y-axis. So this is down up. So the end behavior is down up. That means when x goes very large negative number, that means the output will go down. That is, y value will become very large negative number. And the same thing is if x becomes very large positive number, that is plus infinity, and the y value become very large positive value y. So I hope you understand. So this is how the behavior. So the and behavior goes down and goes up. So that's the and behavior. And this is a polynomial function with degree 3. And because it is positive, so this positive sign decides down up. Just imagine if the same thing was minus 2x cubed, then the graph will look different. The graph will look something like this. See? It goes up and then goes down. And watch this question here. There is a minus 1x raised. This is the leading term. And in the leading term, you see there is a degree is 4. Degree is 4. That means even number. And the leading coefficient is kind of, you have to be careful with the leading coefficient, which is minus 1, the number that multiplies x raised to 4. But because if this was plus, I'm just imagining if this was plus 4, the graph will be something like this. Say this would be your graph. On either side, it will be plus, up, up. But because it is minus, this graph, instead of up, up, goes down, down. It means this graph will look like something like this. See? So that means it is down and it is down. So what does that mean is as x becomes very large positive value, and again I'm writing again and again I'm writing this, this goes down. Okay, so down, the y values become very large positive, sorry, very large negative values. That means larger and larger negative values. And the same thing when your x value become very large negative number, that is minus 50, then the graph goes down. That is x becomes minus, sorry, the y value become minus infinity. So they become larger and larger negative values. Let's go to question number 2. So the second problem is state whether the degree and the end behavior of this. And explain showing your reasoning. Now look at this problem. This is a, a cubic polynomial because so the degree is, so what is the degree here? The degree is 3 and the leading coefficient here, the leading, so everything depends on this. So two things. One is the leading, the degree 3. The moment you have a degree 3, what should you keep in mind is that the graph is going to be down up. So that's how it is going to be the graph. The end behavior is down up, and then here if this graph is when it is plus x cubed. So the leading term, the leading coefficient should be maybe 1 plus 1 x cube or plus 2 x cube or plus 3 x cube, doesn't matter. As long as it is plus, this is how the. But in this example, if you see, the leading coefficient is negative 1, so there's no number. So what does this minus x cube basically is minus 1 is multiplied to x cube. This number, what it does, it flips this graph. So instead of this graph, the graph gets shifted. So I mean, graph gets flipped across the x-axis. It means if I have x-axis, this is x-axis, eh? So the graph now get something like this. Okay, so the graph uh, flips the flips over the x-axis. I hope that makes. So the end behavior, the state, the degree is 3, and the end behavior is as you. So this is what the meaning of is as. So the end behavior becomes as you make x very larger and larger in the positive direction, positive number. The y value. So this means as x become larger positive number, y value becomes negative infinity, goes down. And as you make x very large negative number, the y values will go, the graph goes to plus infinity in the positive direction. That means y becomes very large positive number, or in the positive direction of the y-axis, the graph goes up in the positive direction. Hope that helps. In the question number 3, the graph of the function is, so you're given the graph, and when you look at this graph, you already know it is a cubic graph and something here. Okay, the question is, what is this? So if you see at the bottom, there are a lot of options there. So how do you decide which is the right option? And you can see the main thing is this part. These are the zeros. If I want to write what are the zeros of the polynomial function is -2, 1, and 3. That means they cross And what are the x-intercepts? So the x-intercepts or the horizontal intercepts. So these are the same thing, but you're going to write with these are the horizontal intercept where the graph crosses the axis. But the question is, when you want to find this, that means if these are the uh, places where the graph crosses the axis, we can create a polynomial function. And how do you create it? Is you are going to have three factors. So here it is. So x-intercepts is x equals -2, and you add 2 both sides, you get x plus 2 equals 0. See? So I just write x plus 2. And the next one is there's a plus 1, so you put -1, and the next one is 3, so x minus 3. So what is the leading term? So we want to know the degree is 3 because you can see the maximum it crosses is this. So the degree is 3. And how do we find the leading term here? If you see, if you multiply this, all of this, so that means it is x times, so that will be x times x times x, that will be x cubed. And what goes here is if there's a 1 here, there's a 1 here, there's a 1 here. So it's like 1 times 1 times 1, which is 1. So this is the leading term. 1x cubed is the leading term. This part is the leading coefficient. So remember that's the leading coefficient. And then what is the constant for this? And the constant means what is the vertical intercepts. That means you're supposed to multiply all these three numbers. That means when x equals 0, so it's like p of 0. So it means you are going to plug in 0, 0, 0, and what stays is plus 3, minus 1, and minus 3. I think I made a mistake, plus 2. I think this is plus 2, right? So when you multiply this, all these three, you get 2 times minus 1 is minus 2, and minus 2 times minus 3 is plus 6. And that's the constant, or where it crosses the y-axis. So that's the 6. It clearly shows here. And the vertical intercept is 0, 6, and you're done. Question number 4 is, what is the sum of this? Now, what is the sum means? You're just adding, right? So you have 2x square plus 2x and minus 10. You're adding this. So I'll write below this, x squared terms together, and there's a plus 6. So plus 6 is here. You can add, and this total will be 4x squared. This 2x remains the same, and that will be 4, and you're done. That's all it is. And this is in the standard form. Okay. So standard form is when you write the terms in the decreasing order of the exponent. This is 1. State the degree and the end behavior. So if you look at this again, we have seen this. There is the degree here is 3 because the highest exponent is 3, and the leading coefficient is plus 4. That means the graph is something like this, down, up. So you have to write again what is the end behavior. So that means as if you do like this, again the same thing, as x become very large positive number, that means the y values become plus infinity, and this side when x become very large negative, then this goes down. So this goes down. So that means y becomes very large negative value. And this question number 6 right here. Select all the polynomial function whose graph has got x. So they gave us the x-intercept this. So each one of them, let's say this is x equals 4, x equals -1, 4, and x equals -2. All you do is subtract 4 both sides and you get x minus 4. That's one factor because this crosses guard, you get 0. You multiply 4 here. So this becomes 4x equals -1, and add 1 and you get 4x minus 1 equals 0. And the last one you add to both sides. So you get x plus 2 equals 0. So these are the three factors, 1, 2, and 3. So all you do is put like this, equal to 0, and you write x minus 4, 4x minus 1. And you look up, where do you see this situation? Do you have this? And you can see clearly x minus 4. If you see that x minus 4, I think this one, Wait a minute. So first of all, you have to have x minus 4 and x plus 2, right? Do you have x plus 4 is there? And this is not the one. And this one has x minus 4, so that's the not one. This one has both x minus 4, that's not the one. Now this one is x plus 4 and x plus 2. That is x plus 2, so, but then this is 4x minus 1. This is also not correct. What about uh, so is this correct? Let's see. E is correct. There is a x minus 2, and this is x plus 2. So this also is. Now, how do we know this may be correct? If you see this, there is a 4 common here. This 4x is right here. I think I made a mistake. Let me see what is the mistake. Let me clean this up. And while adding, I made a slight mistake. Let me correct this. So this is minus, so you are adding plus 1 here. So this is going to be plus 1. So your main equation is x minus 4, 4x plus 1, and then x plus 2. So all you do is look up for which one may be the probable candidate for that. And if you see this x minus 4 and x plus 2, so x minus 4 and this is one of the answers. Clearly this is correct. It's the same thing that you see. Then y, this is correct also. And you can see this one, you can pull out 4 is, there is a 4 which divides both of them. So we can write 4 of x minus 4 because 4 times x is 4x, 4 times minus 4 is 16, and that takes care of this term. And the rest is correct. And you're done. So this also is correct. So hope that helps. Okay, in graph, now here we have to draw a rough sketch of the graph. So they give us the factor form. The first step to know really sketch is, there are 3 of them. So 1, 2, 3. Maybe it is this way, or maybe it is this way, or maybe it is this way. So that's all it is. We have to know. How do we know what does it look like? So if we have this in the factor form, all you do is figure out what are the zeros of the polynomial function. Put it equal to 0 and figure out the 0. That means each one of them you put equals to 0, and x plus 1 equals 0, and 7x minus 2 equals 0. And when you solve this, you add 3 both sides, you get x equals 3. So already that's one of the x-intercept. You subtract 1 and you get x equals minus 1. That's another one. And you add plus 2 here, and then and this becomes 7x equals 2, then divide by 2, so this will be 7, so you get x equals 2 7, uh, which is almost 0 point maybe 2 and something. I'll just write 0.2. So when you want to graph this, so how do we sketch this is, we need to put this point x equals minus 1. So minus 1, let's say this is minus 1. This is 3, so 1, 2, and 3. So that's 3. And then this is 0.2, maybe here somewhere here. This is 1 and 2, 0. So these are the x-intercept. The numbers are the zeros. And how do we sketch this? You can also figure out what is the y-intercept. To find the y-intercept, you plug in the equation, you put x equals 0 and you just multiply the numbers this. So it means you are multiplying minus 3 times 1 times minus 2 and you get plus 6. So that means the graph 1, 2, 3, 4, so 5 and 6. So that's the point. So the graph goes through this point. So this is the vertical intercept, that is 6, and we have minus 1. This is the 0.2 here. That's 2. So we need to sketch the graph, and it doesn't have to be correct. And how do I start it? Because it is x x x. So everything is positive. So plus plus. So it's going to be down up. So it has to be taking this shape. So I'm going to start with down. So it starts from down. See, and then it crosses this graph. Yeah, and then it goes up and maybe takes a turn. We don't know where it takes a turn, but then it takes a turn somewhere and goes through 6 and then passes through this one, okay, to +2, and then somewhere it takes a turn. Again, we don't know where it takes a turn, and then it has to go up like this, and then that's the graph of just a rough sketch of the graph uh, of this function, whatever is given there. I hope. +1, -1. Yeah, that's it. So again, I repeat, if you are given this three factors, means going to be a cubic polynomial. That means you are going to get x raised to 3, and you know it has to be this way. And why you know this is plus is because it is x and x and x and x. Just imagine sometimes they trick us and write 3 minus x, then you have to be careful. Everything stays the same, and if this was the case, then it's not going to be down up because this is 3 minus x. You'll have to put x, you have to change the order like this. Okay, and then this will be down, up, down. So that's to be taken care. Okay, so let's go to the. Okay, so draw the rough sketch of the graph. Now this one is again what is this? Basically means x plus 1 and x plus 1. It is repeated twice, and that's why we have the zeros. So what are the zeros of this is opposite of plus 1, which is -1. Opposite plus 1 is -1, and you say 4. So when we write, we just say, okay, so the 0, which is -1 is a 0 with multiplicity. So this is a new vocabulary, multiplicity with multiplicity 2. So that means, what does it mean is basically means is at -1, let's say this is -1, the graph does not cross like this. So the graph is going to take a turn, maybe something. So either this way, maybe, or this way, but does not cross like so. That doesn't work. So whenever it is a even, so multiplicity is 2 or 4, 6. So you will see either the graph takes a turn at that point. So when we want to sketch the graph of this function, let's see, this one is a three factor, so it has to be something like this. So let's see how to graph this. Draw x-axis and the y-axis. Okay. And the point is -1. So the main thing is this is -1. And also at 4. 1, 2, 3, 4. This is 4. So these are the main points where we have to. Now because the graph, also you can see, uh, because I wrote this in the three factor, this plus 1 and this plus 1 multiplies to get +1. And again you multiply -4. That will give you -4. That means the graph has to go 1, 2, 3, and 4. So the graph has to go through y-axis at minus. So there is a vertical intercept at. So how do we graph this now? Now remember, it has to be down up. So I'll start from down. So if I start down, and remember you have to pass through this also. So it takes a turn somewhere at here. So it takes a turn, then crosses this, and it has to also cross this. See, so it has to cross this. So I'll have to extend it down, and that's how now whether it is this way or this way or this way, we don't know, or maybe this way, we don't know. So but then the main idea is once it crosses -4, takes a turn somewhere, and then goes this way, and you get the graph. That's it. So hope that clarifies this one. That's the sketch of. So your question is why this took a turn, because it's the repeated at -1 you have the 0 of -1 is a 0 with multiplicity 2, so it does not cross. So hope that helps. Uh, but then it's better to figure out what is the vertical intercept by plugging in x equals 0 and then multiplying the numbers so that you can get the constant term. I hope that helps. So, so question number 3 basically is asking you use technology in case if we, but we can graph this without that technology. Let's see, can we become the human calculator? Predict the end behavior of each polynomial function. Oh, so you're supposed to know what is the end behavior of each one of them and check your prediction using technology. Now, if you see this, there are four factors. So at the most, your x-intercept will be opposite of +3 will be -3, opposite of -4 will be +4, and opposite of -4 is +7. But because there is a 3, you have to divide by 3, which will be 2 1/3, right? This will be x equals opposite of -3 is +3, and then divide by 4, which is right here. So 4, 3, 4. So, and then because there are four factors, the degree of the polynomial is 4, and they are all plus. If you see this, all x's have leading, the coefficient are plus. So this is plus x, plus x, plus x, and plus. So that means it is going to be plus. And if you multiply all of this, and if you see the multiply, it becomes x raised to 4. And this 3 and this 4 becomes 12. X raised to 4 is the leading term with the leading coefficient of 12. So how do we sketch this is let's draw x-axis and the y-axis. So main points are -3. So 1, 2, 3. -3 is one of this. And there is a 4, 1, 2, 3, and 4. That's another one. 2/3 is somewhere, maybe this is 2. So this is 2/3. And 3/4 is somewhere here. And remember, when you multiply all this, 3 times -4 is -12. So that, so if I multiply you want to know where the graph crosses the y-axis. So 3 times 4 is -12, and -7 and 3 is 21. And if you multiply this, it's going to be a big number. So if I multiply 12 and 21, 2, 1, 4, and 2, oh my God, that's becoming a big number. It's going to be, when you multiply, it's going to be a negative. That means the graph. So because it is a degree 4, the graph has to look alike. And because there are 4 of them, 1, 1, 2, 3, 4. So that means something, it has to cross, x-axis has to cross 4 times. So because this is the extreme left 0, so I'll start from down. Okay, so this may be going down, and somewhere it takes a turn. I don't know where it takes a turn, but it will cross this at -252. So what I'm going to do is, and maybe it's coming back here, it will go through this point, then takes a turn and goes through 2 1/3, takes a turn, and then that's how the graph is. The only thing is I did not show you is where this goes down. See this part? So this goes down and it will cross this, the 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 y-axis at -252. So the main thing is the end behavior, and you can see the end behavior is x becomes very large positive number. The y value becomes also very large. On either side, when x becomes very large negative number, then y also become up. So this is up. So positive. That's the second one. Now look at it. This B question is what is this basically means is it is 3 minus x and again 3 minus x and then 6 minus x. And the first thing is I want to write x first. This is x minus 3, and this again I can write as x minus 3 but minus 1. So it's like you're taking -1 outside. When you change the order, you have to multiply -1. And again, I multiply -1 here, it becomes x minus 6. So eventually, this two negative will make it positive, and there is x minus 3 and x minus 3, and there's a minus, and this minus sign will be outside here. So this is minus, and this is the final product of the equation. But then you can see this x equals, so x equals 3. This is the repeated 0, so repeated. So with so it so the function the polynomial function has 0, 3. So the 0 is 3 with multiplicity 2. So there is a turning point there. And and then we also want to know what is the constant. So this means when you multiply this become plus 9 and then you multiply this become minus 54. So that means when you graph this, so I forgot here. Okay, this is 6. So the zeros are, so the x-intercepts. So the x-intercepts are, is x equals 3 is 1 and the other one is opposite of minus 6 is x equals 6. So you have to have 1, 2, 3, 4, 5, 6. So this is 6 and there is a x equals 3. This is the 3, right? And there it is repeated and it goes through uh, minus 54. So where do we start? And because this is minus sign, so when you multiply minus 3 is positive 9 and positive 9 is minus 6. So that's minus 54. But because there was a minus here, which I forgot, in other words, what is the vertical intercept is when I plug in x equals 0, this b of 0, just want to show again, it is 0 minus 3, 0 minus 3, and there's minus outside, 0 minus 6, and then you see there's going to be minus 54. Sorry, plus 54. Because this minus and this minus 54 will make it positive. So that means somewhere down up, it goes up, somewhere it crosses at 3, the graph takes a turn. That means the graph comes from up, I think somewhere up. So this, it goes, comes down, takes a turn like this, okay? And then takes again turn and then crosses. So x equals 6. So this x equals 6, which is here, right here, is of multiplicity 1. So because there is just a factor, right? X. So this is just x, one factor. There is no square. There is no square like this. So that's why it has to cross at 6. So it crosses at 6, but takes a turn at 3. Now we don't know whether it is this way or this way or this way. That's not an issue. So we don't know that part. But this is we exactly how up you go this. But remember, it will cross the y-axis at plus 54. So you can zoom, you can adjust the y-axis there and show also on the desmos.com and you say, okay, let me shrink this and make this as, let's see, I can write this as 10, change this as 10, 20, 30, 40, 50, and 60, and then 54 will be somewhere here. So, and then the graph crosses like this. So this is the graph going to cross. So this is how the graph will be. If you try to adjust your y-axis, you can do that. And we can also check this using Desmos here. If I click on desmos.com and I think, and then click on this calculator, okay, and I want to put it was 3 minus x and raised to the power 2, and then it was x 6 minus x 3 minus x. Clearly see, and this one, if I can adjust this y by maybe 70. Look at this, and beautiful graph, and the bottom part also would be changed to minus 20, 30 maybe. And clearly the graph, there is a vertical asymptote which is 0.54. And that's where the graph takes a turn at 3 and there is a 6. So these are the horizontal intercepts. So the x-intercepts are 3 and x is 3 and x is 6. And the zeros are 3 and 6. So done. Okay, let's move on. Oh my God, look at this. Let's check on that. I want to write this in the factor form. So, and then I'm going to change this order because I want x first, and then this is like minus. So you're multiplying minus 1 inside. So that will become 3x minus 4. Okay, it's because minus of 4 minus 3x, and if I multiply minus 1 to this becomes minus 4, and minus 1 to become 3x. That means it is 3x minus 4, right? So I write this first, and then I have x. There is a x raised to 4. What does this mean? Is x minus 0, x minus 0, x minus 0, and x minus 0. That means this function is 1, 2, 3, 4, 5. It's a quintic function. So the maximum zeros that this function can have is 5. So we have the zeros. So the zeros are 0 with multiplicity. So the multiplicity here is 4, and the other one is the opposite of minus 4 is minus 4, and divide by 3 because there's a 3 here, which is minus 1/3. And this is with multiplicity 1. So that means at x equals minus 1/3, the graph crosses the x-axis. But x equals 0, the graph at this point, the graph is going to be taking a turn. Now, how the graph will look like? Remember, this is quintic, degree is 5. The regular graph for quintic is something like this. See this part? So this, sorry, I made a mistake. So the regular graph of degree it takes 4 turns. 1, 2, 3, 4. So this is how, and this crosses. Suppose I draw a line like this. That means the graph crosses 1, 2, 3, 4, and 5 places. But right now we will try to graph, but in the flip. The graph is the flip of the original uh, function. So even though the graph has to be something like this, but now we have wait a minute. No, so it is going to be down up. Look at this. So this is going to be down and up, because there you go. This is the equation, right? Because just because this minus doesn't mean it has to be something like this, okay? But because this has got adjusted, and you got 3x minus 4 right here. So the graph is going to the zero. One of the zeros is this one, and the other one, let's say if this is minus 1, this is minus 2, and this is minus 3. That means minus 1/3 will be, you can split this into 3 parts. This will be minus 1/3. So that means these are the two places where the graph either crosses the x-axis or takes a turn. Now, because it starts from down, I'll start from down. Look at this graph. So I'll start from down, and this x equals minus 3 is a 0 with multiplicity 1 because it's not repeating, right? So it's just raised to 1. That's why. But the other one, there's a 4. See, it is 1, 2, 3, and 4. That's why it is 4. So it crosses this, okay, somewhere, and then takes a turn, and then somewhere, and then at this point does not cross at 0. So it has to be something like this. And because it is x raised to 4, basically you will see there's more flattening here. What did that mean is this graph goes like this, but then it's something like this. So this is how because of that 4, it's not going to be this way. Maybe the x square could be like this, but because it's x raised to 4 is like this. So it takes a kind of flattens here and then goes up like this. Now we want to know how does the graph look on the desert. And you can see this graph. I just thought of graphing this. You can see this. It takes that's the minus 1/3, and this is 0. And I just try to adjust. I don't want too much of y values. Let's make it just 30, maybe. Uh, maybe 10. And it will look more better. Sorry. Okay. And I don't want too much negative, and I just put minus 10 here. There you go. See, that's what I was talking about, flattening here. So it crosses at this point, and then at 0, it flattens. And let me take that. See, this is how it is. The graph. The zeros are minus 1/3, and this 0. So at minus 1/3, the graph crosses the x-axis, and at 0, it takes a turn, but it flattens at the same time because it is x raised to 4. This 4 makes it flatten there. And if you try to grab the other one, let's there's another one which is 6 minus x. 6 minus x. 6 minus x and to the power. And there was, I think, I forgot. What is it? Okay, 6 minus x raised to 6. And because there's a 6 there, and you see it flattens more. Let's see, it goes up and 6. And look at the graph. It can't even say, I'll zoom out here. And there it's the graph. See, at 6, it flattens here. So that's all it is. I hope you guys, and behavior is up, up. And see, I can then write more here. So x becomes very large positive value, the y value takes very large positive. If you take x become very large negative value, again it is up. So hope this graph helps. So the question number 4 is what happened here? Okay. Question, which term can be added to this so that it makes 10th degree? So now if you look at this, the degree right now which shows is degree is 7 and he wants to have degree 10. So naturally it has to be x raised to 10, right? So the only option is this. So all you do is you add here. So it becomes x raised to 10 and the rest, everything stays the same. And that's it. So this is a polynomial function with the degree 2. That's it. That's all the question was. So question number 5 is saying if you look which represents, so there's a f of x graph and there is a gx graph. I'll put these colors to see. Now, both of them have the same factor, which is x plus 1 and x minus. What does it mean is they cross the x-axis as opposite of plus 1 is minus 1 and opposite of minus. So these are the places, these are the x-intercepts or horizontal intercepts. So they both cross the same numbers. But then how does this do? What does this to do is so the gx, there is a number before. So whatever the y coordinate this one has, so whatever the f of x. So first of all, the black color is the first one. Let me explain to you. So this black equation is the graph, this black graph. See, this is the graph, which is the first one. And the question is, what happens here is, if you see at somewhere here down here, this point, whatever that point is, that doubles. So this means anything that you have here, whatever the values, whatever this values, you have to multiply by 2. So imagine if this is like, I think this point is almost like, I don't know, it is 2 negative 25. And the point on the first, this point, maybe I'll make it like 12.5, maybe somewhere here, and that is minus 12.5. So this is 2 negative 12.5. So what's happening is this point is, so there is a vertical stretch of this point. The graph, this one, gets vertically stretched downwards and by scale, and that this 2, which is also called scale factor. That means the original graph is stretched by a scale factor of 2. So it goes down. Look at this. So it goes this point. That's all. So the dotted line is the gx and the solid is the f of x, and that's it. So how do we know it becomes skinner? Look at this. It gets stretched. So this graph, the dotted, is a skinny one, which is the graph after stretching downwards, so vertically stretching by scale factor of 2. So every y, which is here minus 12.5, is multiplied by 2. So minus, when you multiply by 2, you end up getting minus 25, and which is right here. So I hope that makes sense. And I think I'm done. Now this question, even though it doesn't show on your paper, I want you to copy this question and write a solution also. Wherever there is enough room, you can write down this. What is the degree of this? So the degree is 3, right? No, no, no. Oh, see, I made a mistake here. So you have to look up for which is the highest exponent. So this is degree, which is degree is 4. And then also you have to decide, make sure the leading coefficient here. So the leading coefficient here is +2. That means if it is 4, it is up, up. You know, the original graph will be something like this, and it is plus, so it is correct. So the end behavior, that means the graph, like see this, so this graph, as I can get the x-axis and the y, something like this, and as the x becomes very large positive value, then the y goes on increasing. See, the graph goes up to plus infinity, and this side, when x is very large negative number, x is minus infinity. Again, the graph goes, the y values go on increasing, and you say, okay, plus infinity, and you're done. And this is the last question, the graph of a polynomial function. So you're given something down, down, right? Select all that is true about the statement. When I look at this, what do you think is, it, even though it crosses, look at this, it takes two numbers so that it crosses twice and it is down, down. The question is it x squared? So looks like we are going to put x plus 2 and x minus 3, but be careful, there are turns, one, and then there is one more turn, and there is another turn. That means the degree has to be 3. So the px, if I want to write the polynomial function and x raised to, it has to be of degree 4. That's one thing. Now, because it is down, be careful, this one is down, this will be negative. So the leading coefficient will have to be a negative number. So this has to be negative. Okay, and the constant term, what is constant term is 3. Right here, the constant term is 3, which is, yeah, the constant term C. So if I want to add here, the last number has to be plus 3 here. And if let's check if there is any more question, or I can create a polynomial right here also. This, by just looking at it, you can write down. So there is a 0 here. Okay, that's 3. So you want to show when you're multiplying. So this is around, so something like this, 4 of them, x, 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 and x. This is minus 2.5 maybe, and becomes opposite here. This is 2.5, so it will be plus minus 2.5. Okay. And because it does not cross anything, this could be, maybe we don't know what it is. Okay. So we don't know this part, but we want to make sure this number will never become 0. So that's one thing we have to be careful. So anyway, here we don't have to write the polynomial function, but main thing is the leading term, the leading coefficient, it has to be negative, and it has to be degree 4, and the constant is 3. Hope that helps, and I'm ending this. I will continue the next video later.